Hello, welcome to the AP Stats FRQ of the day. Hope you're doing well today. So let's see if we can figure this one out. So this one's the 2015 number 2. So here we go. So to increase business, the owner of a restaurant is running a promotion in which a customer's bill can be randomly selected to receive a discount. When a customer's bill is printed, a program in the cash register randomly determines whether the customer will receive a discount on the bill. The program was written to generate a discount with a probability of 0.2. That is, giving 20% of the bills a discount in the long run. However, the owner is concerned that the program has a mistake that results in the program not generating the intended long-run proportion of 0.2. The owner selected a random sample of bills and found that only 15% of them receive discounts. A confidence interval for P, the proportion of bills that will receive a discount in the long run, is 0.15 plus or minus 0.06. All the conditions for inference are met. Part A, consider the confidence interval 0.15 plus or minus 0.06. Part 1, does the confidence interval provide convincing statistical evidence that the program is not working as intended? Justify your answer. Part 2, does the confidence interval provide convincing statistical evidence that the program generates the discount with a probability of 0.2? Justify your answer. All right, and so then a second random sample of bills was taken that was 4 times the size of the original sample. In the second sample, 15% of the bills received the discount. Part B, determine the value of the margin of error based on the second sample of bills that would be used to compute an interval for P with the same confidence level as that of the original interval. And Part C, based on the margin of error in Part B that was obtained from the second sample, what would you conclude about whether the program is working as intended? Justify your answer. So if you want to pause your video and give this a shot, so go for it. Okay, so this is this is a problem that requires no calculator work, and that typically a lot of times happens on the AP exam. You will have to have a calculator and use a calculator in the exam, but a lot of them are really conceptual like this. So anyway, so we've got this confidence interval with 0.15, and he wants 20% of the bills to have a discount, and there's his confidence interval with his sample. Now, we don't know the sample size. All right, but we do know what the interval is, and so the margin of error here is 0.06. So every margin of error is, it's every confidence interval is 2 margins of error wide. So the confidence interval itself here is 0.15 minus that, which would be 0.09. Okay, and 0.15 plus that, which is 0.21. So those are all the plausible values for P. And by the way, they define P up here for you. So if you had to, state what P is, then you need to say it like they say it. It is the proportion of bills that will receive a discount in the long run. So you need to say it like that. And so does this confidence interval provide convincing statistical evidence that the program is not working as intended? Now make sure you answer that, properly answer the question. So it's saying that it's not working. And so this is the way I worded this one. So if you notice, you would say no. All right, 0.2 is in the interval, so it is a plausible value for, and then you have to say you have to state the context. It is the plausible value for the proportion of all the bills that will receive a discount in the future. Okay, so that's the proper answer to that. 0.2 is in the interval, therefore it's a plausible value for the parameter, and say what the parameter is. All right, and then so part B, does the confidence interval provide convincing statistical evidence that the program generates the discount with a probability of 0.2? In other words, because 0.2 in there, is that really evidence for it? And the answer is no. All right, the answer is no, because 0.2 is just one of the values in the interval. Okay, all of the values in this interval are plausible. So the fact that 0.2 is in there, we're saying it is a plausible value for P. It is a reasonable value for P. We aren't saying we have evidence for P, because in essence, all of these numbers in here, everything between 0.09 and 0.21 is plausible. So that would be the proper answer to that. And so then, okay, a second random sample of bills was taken that was 4 times the size of the original. In the second sample, they still had 0.15 as their point estimate. Determine the margin of error. So what you have to realize here is the formula for margin of error. So our formula of margin of error, if we wanted to look at our formula sheet, every confidence interval is critical value times the standard error of the statistic. And so critical value, so the margin of error is our critical value, Z star, and then the standard error of the statistic. So for proportion, there it is. It'd be the square root of p hat times 1 minus p hat over n. Now, you could, just enter in values. They didn't give you a confidence level here, so you could just try 95% and see what happens when you multiply it times 4. Or you could just realize this, is that the margin of error is inversely related to the square root of the sample size. So it's inversely related to the square root. So if you multiply the margin of error, in essence, if you multiply the sample size by 4, you're multiplying the margin of error by 2. But you could, say, okay, let's just say it's 95%. I go 1.96, the square root of 0.15 times 0.85, and then make it like 100, okay? And then do the same thing with 400. And see what happens to your margin of error. And you would notice that it gets doubled. So, but I think the quickest way to answer this problem is what I said here, is multiplying the sample size by 4 would make the margin of error half as big, as it is inversely related to the square root of the sample size, like that. Thus, the new margin of error is 0.03. So that's, you had to say that to get it right, you had to say it's 0.03, and you had to provide some reasoning. Here's some reasoning, or like I said, you could have made up some values for n and done it that way. And then lastly, based on the margin of error part B, what would you conclude about whether the program is working as intended? Well, with the new margin of error, 0.3, the new interval is 0.12 to 0.18. This interval does not contain 0.2, so 0.2 is not a reasonable value for P, which is the portion of all the bills that will receive a discount. Thus, the program would not appear to be working as intended. So there you go. There's your FRQ of the day. I hope you got something out of it, and I look forward to talking to you guys again soon. I hope you guys just have a beautiful day today. It's lovely weather outside right now. I think I'm going to go golfing later, by the way. But anyway, look forward to seeing y'all soon.